So welcome back. Today I'm presenting Hadoop architecture. So Hadoop is used when data becomes too big for a single computer. For example, student records of million students. Just think of a scenario, millions of students cannot be stored processed in one system cannot store all the data of million students, right? So Hadoop uses many computers together to solve these problem. So millions of students data is stored separately in many computers. That is what Hadoop does. Okay, so Hadoop works on master slave model. So master slave model in the sense there will be a master node, let us say a class teacher, and he will be appointing some CRs and deputy CRs to do work combinedly. So for example, I say to form groups. So class teacher cannot come to you and say who will be the three members in the group. Okay, CRs will be working collaboratively with classmates such that at the end master node, that is nothing but class teacher, knows which group the three members belongs, or which group, how many groups are formed in the class. So the work is distributed. So these CRs we call, in terms of big data, we call them as slaves. Okay, so the master gives just instructions, slaves do the actual work. Okay, so Hadoop separates storage work. Okay, so Hadoop separates storage work and processing work differently. So this makes the system faster and efficient. So one class teacher assigns works to many students. That is what this thing. So class teacher here is master. Students here are nothing but slaves. So this is nothing but Hadoop completely works on master slave model. Now moving on to the architecture of Hadoop. So HDFS stores the actual data. So HDFS stores the student data, let us say. And here, if you see here, Yarn, yet another resource negotiator, manages, okay, computer resources. So how much resource I need to allocate for this particular task? How much CPU I need to allocate for this particular task? That Yarn decides. So MapReduce process the marks. Okay, so it checks how many marks each student got. Okay, that is what the task of MapReduce. And Hadoop Common, if you see here, Hadoop Common supports everything. So it will be used, it will be worked on Java library and utilities, and Hadoop Common supports everything in this particular architecture. So these all components work together like a team. Okay, this is what about the architecture diagram. Now moving on to the layers of Hadoop. So Hadoop has main four layers. One is storage layer, that is nothing but HDFS stores student files. Second one is resource management layer, that is nothing but we call it as Yarn, which manages memory and CPU. And the third layer is nothing but processing layer. So MapReduce calculates the results. Okay, MapReduce calculates results. And the last one is nothing but utility layer, that we call it as Hadoop Common, which provides us all the tools. So each layer has one clear job. Okay, each layer has one clear job. Now moving on to the specific layer, that is nothing but storage layer. So HDFS stores very large student data. Okay, if student data is very big, okay, Hadoop will split into blocks. So blocks are stored into many computers. Okay, for example, let us say I am having 512 MB. So I will shift it into four blocks, four equal blocks, 128, 128, and 128, 128. So copies are created. Even if this 128, one more copy will be there. One more copy will be there. If some system fails, I can get the copy. So university is storing 10 years of exam results safely using Hadoop architecture. We can store, okay, by this is nothing but we call it as distributed system. Okay, so we are not storing that 512 GB or 512 TB in one system. If system cracks or system crashes or system failure or system malware attacks, the data will be lost, right? So what I am doing, I am dividing the data and storing it in different computers, and I am also creating one replica of those computers such that if any computer fails, okay, I can retrieve my data as it is. That is what the main advantage of Hadoop. Okay, so in Hadoop also there will be some main components. So first one is name node, or we can say master node. Name itself has some answer for you people. So second one is nothing but data node, slave nodes. So I think you got it right. So third one is nothing but secondary name node, which supports the data node. So each has different responsibility, just like school staff. Okay, I will explain all those in coming slides. This is the architecture diagram for HDFS. Okay, so if you look here, client will be giving some data to name node. So for example, student, let us say student is nothing but client, ask for data. So name node tells where the data is. Okay, for example, if you come to me and ask for your attendance percentage, what I search, third year C section attendance. So name node is nothing but it says here there is the Excel file that contains the attendance. It does not show the what is there in Excel file. It just say the file name here in this folder, that file name exists. Okay, so name node tells where data is. Okay, the name node does not say what is there in that file. Just say the file is there in your system at the desktop. That's it. So data node here, data node provides the actual data. So client never directly controls storage. Okay, that is what you need to remember. Student ask office nothing but name node, and office tells classroom. So classroom here is nothing but data node, and teacher gives the answer. So teacher here is nothing but again data node. Okay, so this is nothing but read and write applications. So if you see these are the data blocks of the particular student stored, and here again if you see, here we are having again replication of those data blocks. So if the computer fails, I will be having the replications. Okay, that is what about HDFS architecture. Now moving on to name node. So what is name node? So name node is the main controller of HDFS, or we can say brain of HDFS. It does not store student marks. It does not store student marks. It does not store student marks. It stores information about marks. Let's say file name. So this file name contains the actual marks. Okay, so it knows which file exists, where it is stored, how many copies we are having of those particular file. That is what the task of name node. Okay, now name node stores student file names. Okay, folder structure, block IDs, locations of blocks. Okay, so this information is called metadata. This information is called metadata. Attendance register index page, that we call it as metadata. So inside that index will be having actual data, but at the index, that index we call it as metadata. Okay, now moving on to another slide. So name node mapping. So name node maintains mapping like, let us say, student file, then it is stored in blocks, then it is replicated into data nodes, the actual information. So when a file is requested, NameNode knows exactly where to find it. Okay, that is what the slide says. Okay. Oh, now NameNode handles, so some it will be handling. So creating student files, creating student files, deleting files, deleting, okay, checking permissions, okay. If NameNode crashes, entire Hadoop system will be gone. Entire Hadoop system stops. Like school without a principal. So think of that scenario. If principal is not there, the system will be collapsed in the school. Okay, that is what happens if NameNode collapses in Hadoop. Now moving on to the second type of HDFS, that is nothing but data node. So data node stores the actual data blocks, that you need to remember. So it does not store the file name of the data, it stores the actual data what is there in that file. Okay, so each node stores blocks, reads data, writes data. So many data nodes work together, that you need to remember. So periodically it is like heart of the Hadoop or HDFS. Okay, the data node is heart of HDFS. So what are the responsibilities of data node? So data node send heartbeat, that is nothing but I am alive. Okay, so it sends block reports, what is there in that block. Okay, they also create replicas. Okay, that you need to remember. So they also create replicate data blocks. Okay, if one system fails, data still exists in another block. Okay, that is what the main advantage of HDFS. Now what is this secondary name node? So it is nothing but it takes like a backup of metadata. Okay, it is like a backup for metadata. So it merges log files. Okay, it edits the log files which are there in the system. So it helps in faster recovery. Okay, it is not it is the backup for metadata, but it is not the backup for name node. That is what you need to remember. Now if you see HDFS architecture, so a 400 MB student record file is divided into 128, 128, 128, 1 and 16 MB. So each part stored on different system. So if you want something, we can access, if we want some data about A, we need to access this particular system. So faster access, and even we are having safety due to its replication. Okay. Now moving on to the main important thing, YARN. So YARN is nothing but yet another resource negotiator. Resource negotiator. So YARN manages resources like CPU and memory. So it decides which student job runs first. Okay, if I want Vamshi to come first, YARN decides that okay, for Vamshi you allocate the memory at first, then followed by Shiva, then followed by Shankar, then followed by Hemant, then followed by Riaz. Okay, it gives the schedulation for the manager or for the resources. Okay, that is what it gives. If you want two process or two students to come and give presentations at a time, it gives the resources for two students and go forward. Then after two, again two. It is nothing but parallel processing. Now if you see here, architecture of YARN. So the diagram shows client submits some job. Okay, client gives some job to resource manager. Okay, and resource manager assigns resources. So they assign resources like exam control assigning invigilators. Okay, YARN is nothing but the same scenario. Okay, Now Yarn has some more three important components. One is resource manager, which allocates resources. Another one is node manager, and the last one is application master. So what is a resource manager? It is nothing like it is like a central authority of Yarn. Okay. So controls entire cluster. Okay, resource manager. Now it allocates CPU and memory for task. Okay, it schedules student jobs. So exam timetable planner. So it gives so and so faculty to assign and such that they make that plan or they make that schedule for the class. That is what the resource manager do. The resources nothing but faculty. These so and so faculty are teaching these subjects. So you and one more faculty will be assigned to just prepare the timetable, and the resources are nothing but so and so faculty teaching so and so subject. That are the resources, and the job is to make the schedule. Okay, that is what about resource manager. Second one is nothing but node manager. So node manager runs on each system. That is what the main thing you need to write. So it manages local resources. Okay, it reports status to resource manager. Okay, this is until this part we have finished the timetable, and it updates to resource manager. That is what the key, that is what the terminology, or that is what the work that is done by node manager. Okay, now moving on to application manager. So application manager or application master creates on each for each application. So it negotiates resources with resource manager. It says Vamshi requires so and so resources. It says Elias requires so and so resources. It says Sami requires so and so resources. So it asks for resource manager such that, let us say, you want some time for preparing, or some time you want to extend some exams. So you ask your class teacher nothing but application master. So application master asks HOD is nothing but here in this particular case resource manager. Okay, so monitors execution tasks and handles failures and restarts. That is what the thing application master do. Okay, now moving on to MapReduce architecture. So MapReduce process large student data in parallel. So if I say big data is big, so it will map for every word. It will map big data, map is map big map, and it will shuffle and reduce in the reduce. It will say big came 2 times, is came 1 time, and data came 1 time. So that is what happens in reduce. It is nothing but map phase, reduce phase, and this internally shuffle. Okay, internally we call it as shuffle. Now MapReduce has 3 phases: map phase, shuffle and sort phase, and last one is reduce phase. So let us go to map phase. So suppose we count students per department. Okay, so mapper output is nothing but CSC, we are having 1 student, EC we are having 1 student, CAI having 1 student, and again CSC is having 1 student in a class. So each record is processed separately. So for one, if you see CSC, there are having 2 students, right? So how does map treats? Map treats them as separate department. Even though they are in the same department, it treats them as separate department, and it initially maps every student separately, even they are in same branch. So that is nothing but each student record processed separately. So, and then mapper converts it into key value pairs. In the reduce and shuffle phase, key value pairs in the sense, if you are here in this particular example, CSC having 2, so that are nothing but key value pairs. Okay, Now shuffle and sort phase. So key value pairs are grouped. CSC is grouped because two students are there, right? They are grouped. So same keys are sent to reducers. So this key will be sent to reducer, such that reducers will say give us output as CSC. From CSC two students are there. So data is stored before final calculation. Okay. Now moving on to reduce phase. So reducer aggregates the value. Okay. So reducer phase, in the reducer phase, from CSC two students are there. Okay. And ECE one student and CAI one student. So final result will be produced and stored in again it is stored in HDFS. So output is written back to HDFS. This is what the architecture of big MapReduce. So some data will be given and each word is mapped. Okay, if it is 10,000 words, 10,000 maps will be there. After that it will be using sort and shuffle filter, such that it will be reduced. It will be saying like for example, Shiva has arrived 100 times, Ramu has arrived 200 times. So the output is stored in HDFS. Okay, that is what the diagram says. Now moving on to the last layer of Hadoop Common. So Hadoop Common is nothing but it provides libraries, Java libraries, APIs, configuration files, and utilities that are required for our program. Without it, okay, Hadoop cannot run. Okay, without Hadoop common layer, Hadoop cannot run. It acts like the foundation of Hadoop. That is what about Hadoop, like Hadoop common. Okay. So let us go through the full summary of the explanation. So student data is stored in HDFS, that is regarding about your marks, your attendance, etc., etc. So NameNode manages metadata. Metadata is nothing but the file names. So DataNode stores the actual data. Yarn manages the resources. Okay. And MapReduce process data. Results again stored back in HDFS. That is what about Hadoop architecture. If you are having any doubt, let me know in the comment section. Thank you guys.